Hello followers. Today we are going to see the topic SQL tuning versus database tuning. Actually, whenever we get the performance issue, what people do, they will immediately jump in and they will start tuning. But first we have to identify which part need tuning. This is SQL level tuning or database level. That is most important thing we should ask. Okay. So the issue may be happening because of one SQL statement. Maybe sometimes it's maybe because of the entire database. Okay. So if you are going for SQL training, first focus on individual SQL statement where the database tuning focus on um, so we should not focus the entire database because the user is saying only this particular application is slow. Then it may be some SQL statement giving the issue. Sometimes what happen, the user may say entire database suddenly went slow. Maybe there is a issue with database. So based on the concern, we have to check. We have to tune SQL or database. Okay. So what is SQL tuning? SQL tuning is the process of improving the performance of an individual SQL statement. The primary goal is to reduce the elapsed time, CPU time, logical reads, physical reads, and unnecessary resource consumption while improving the execution plan. So if it's SQL tuning, just we will check the top SQL and we will see the plan and we will try to reduce these all aspects. Okay, these all metrics. What do we analyze during the SQL training? What are the things we analyze? First, we will see the explain plan. So, seeing the explain plan, we come to know how the Oracle execute. Then access path. Okay, it's going which kind of scan? It's going full table scan, index scan, or any other access method and access method. This is access path we will verify. Then we will check index. The appropriate index exists or if it exists, it's used efficiently or not. There is a third thing. Third, statistics. So we will check all the table level, column level statistics and histograms. And we will check joins. What are the join order is using join method, join condition and coordinate estimate, which all we will check. Then finally, SQL statistics. Okay. So we will review the SQL statistics, how much time it's taking. Okay. So for SQL tuning, first we will run the SQL statement from the V $SQL dynamic performance view, order by elapsed time descending. So it will give the SQL top SQL first. In that, these are the columns we will check to identify it. Then we will run the plan. Okay, we will run the execution plan and we will see how it's executing the statement. Okay, that is the SQL tune. Okay, and if we identify that SQL ID and what is the execution plan, then what we'll do for that particular SQL ID, we will create a tuning task, SQL tuning task, and we will check, and it will give the recommendation and what are the information why it's having. Okay, so querying the dynamic performance view itself we come to know. Okay, with so no need of any UI tool, directly checking this dynamic performance view we can see. So we will create tuning task for the particular SQL ID and we will run it and we will see it. Okay, this when it's happened, the user is saying only particular application is slow, then we will check the SQL and try to tune it. Okay, then apply the fix and you can validate. Okay, before applying the fix, collect all the stats. After the fix, collect the stats. Then compare it. Then you come to know. Okay, what is database tuning? See, the user raised the concern. Suddenly, the entire database slow. Then there may be the issue with resources. Okay, So then what we have to do? We have to check the resources. So any CPU, memory, IO storage, these are the aspects any problem is happening. Maybe because the entire database is slow. Then we have to check all these metrics. Okay, CPU, memory, IO, SGA, PGA, redo, undo. These all metrics we have to check. Okay, parallel execution, database configuration, node load. Okay, so database tuning, so we have to check system level. Okay, system level time model. So this is a important dynamic performance view. System model, systematic metrics, and session time model. These are the three important dynamic performance view. We will check and we will identify what is the load of the CPU and DB time and CPU time, and we will check SGA and PGA. So these are the three dynamic performance view. The memory, SGA memory, how it's allocated and how it's used. Those checks we will do. Checking this dynamic performance. IO is more. Then we will check this uh, this DB sequential read, how much it's happening, scattered with how much happening, any direct path write or direct path read or direct path write, and temp direct path read or direct path write. This all aspect we will check. IO level any issue is happening. Okay, wait events analysis. So we can check any resource are waiting. Okay, so there may be the issue with waiting event. So we will check wait event aspect as well. Okay, so these are the few metrics we can check it. Okay, wait event. So sequential read means it's single block IO and scattered multi-block IO. So log file sync, commit or redo related. So these are the checks we will do. Okay. So SQL tuning, what we will check? Individual SQL statement. Database tuning, we will check entire database. Okay. We will see execution plan. Here overall workload we will see. We will see what are the indexes used, those here CPU level. Okay, join methods, here memory is access path, here IO. Okay, here cardinality, here wait event, here SQL statistics, here concurrency. So we can use directly $SQL. Here AWR we can see the system health. Okay, so here explain plan, it's active. Yes, it's active session history report. Okay, we can use SQL DBMS SQL tune, here ADTM. So ADTM also tool only. Internally it may using the dynamic performance only. Okay, but this is a user friendly UI tool. Using this tool we can see it. Okay, so Oracle database give all the details, the dynamic performance views, metrics and statistics. Using this detail itself, we can able to identify what is the issue for user friendly, and we can take some UA help like ATM or Oracle Enterprise Manager. Those things we can use it. But if you are core performance tuning engineer or core developer or DBA, directly checking the dynamic performance view, you can able to identify the issue. Okay. So then real world scenario. So when we can see the SQL tuning. Okay. User report that only particular application screen is slow. So the user is saying only particular screen is slow. So in SQL that on SQL consume significant resource. Okay, first we will do, we will check, we will identify what is the top SQL ID currently running. We will take that SQL ID and we will check it the plan, and we will create the tuning task and we will validate it. Okay, or else in the particular SQL statement itself we will check, wow, any um, coding standards not followed or any index is not used. Those are the checks. What are the tuning expected, what are the checks needed, those checks we will do and we will fix it. Okay, but database level tuning, when the real version suddenly the user raise the concern, multiple application suddenly becomes slow. Okay, maybe this may be the database level tuning record. So this is the area we have to check it. Okay, and then okay, this is the flow. Okay, first we will identify the performance problem, then measure the performance, then we will identify bottleneck. Okay, so now SQL problem, then SQL tuning, DB resource problem, then we will database. Okay, here mostly DBA will take care. Here the developer will take care. Okay, so depends on your role, you will be taking care of. So if it's SQL tuning, DBA what they will do? They will connect with the developer and they will raise it with um, developer. Okay, these are the application going slow. So check this SQL. Okay. If it's resource problem, the DBA will connect with, he may fix his own if it's his area. Sometimes it may be different administrator, maybe it's OS or network level. They will connect with them and they will fix it. Okay, okay. DBA play the key role while performance issue raised. Okay, he is the person connecting with all the teams. Okay, it may be developer, it may be DBA. So he will be the all-rounder in the project to handle the performance. Okay, if you are the performance engineer, so mostly you are half DBA. Okay, always you will be knowing, you should know what are the basic things we have to check and identify the problem. Okay. So recommended performance tuning methodology. These are the methodology. 6 steps. First, we have to define the problem. We have to measure it, identify the bottleneck, that determine the scope, then apply the solution and validate it. Okay, these are the 5 steps we follow the performance tuning methodology. Okay, what are the common mistake? What happens sometimes once issue has arise, immediately they will create the index without analyzing. But it's not maybe the because of the index, so we have to do the proper analysis, then we have to create index. Okay, parallelism, so suddenly they will increase the parallelism, maybe it's not required the parallelism, so we have to check why it's going. So more parallelism can increase the CPU memory temperature and px context. Okay, so first we will analyze, then we can increase. Okay, so don't increase immediately. So the increasing SGA BJ memory. So without analysis, you should not increase this. Okay. First we have to identify, then only elapsed time. Okay. Sometimes the people look only elapsed time and try to do that. Don't do that. Check all the aspects, then tune it. Okay. So tuning without a baseline. So most of the time I see once the issue is raised, immediately they will start tuning. Don't do that. First take the baseline. So what is the um, current statistics before tuning and save it all the metrics. Tune it. Then take the statistics and compare it. Then you can see the difference. What is the difference? Okay. Or else you don't have the any evidence what are the tuning you have done and before tuning what are the bottlenecks. Okay, so don't do these mistakes, make sure all of this will be taken care as part of tuning. Okay, the interview questions. Okay, before interview just go with practical demo. Okay, so just run this. First identify the skills. Okay, so it will give the top skills. Okay, just I will pin it. Then this is the top SQL. I'm taking the SQL. Then we'll run the stats. Okay, the plan. Okay, maybe it's very less. It's millisecond level. That's why it's not showing in the plan table. Okay, so that's why it's not showing. Okay, it's very minimal, then you won't see it. Okay, so if you are if you have your SQL ID is having issue or it's having the good amount of metrics and statistics, then you can see it. Okay. So let's create tuning for this one. I'm creating the tuning task for this. Okay. Then I will show how we create the tuning task. So now I am creating tuning task for this ID. Let's see. Okay, so yes, now I will create 0, 1. I'm creating the task 0, 1. Yeah, I created the tuning task 0, 1. Now what I can see, I will check the tuning task using advisor task. So here I can see. So here it will give the details. So it's execution started and that. So we don't have much complication in the SQL ID. That's why it's completed very fast. Okay. Then you can see the unique task. If you see, it will give the details. So general information and it will give the details. Okay. Additional information. If it's a tuning advisor, it will be giving if it's identify any bottlenecks or those detail it will give. Okay. So seeing the dynamic performance view itself, we come to know. So this tuning SQL tuning tool package only, it's internally it's using the dynamic performance only. So from there it will get the details and it will display. Okay. So we can run the advisor and we can see it. Okay. So so these are the important performance views. So if you want to see system level, you can use this session level. It's a system metrics. Then these are the memory level checks. Okay. So in this video, just I explained how we can compare SQL tuning versus database tuning and how you can identify top SQL and you can tune it. Okay. So these are the learnings in from this video. Okay. So interview question. Okay. What is SQL tuning? SQL tuning, it's optimize individual SQL statement to reduce the execution time and resource consumption. Okay, so if you are tuning the single SQL statement level, that is SQL tuning. What is database tuning? It's tuning in the overall database level, including CPU, memory, IO concurrency, and configuration. How do you identify the expensive SQL? Basically, we will use $SQL and we can see these other metrics. Okay, what is DBMS expression used for? Display the execution plan and where available runtime results. Okay. What if all the application becomes slow? Maybe there is database level bottlenecks such as TCPU, memory, IO, contention, and overall workload. Is session part of database tuning? Yes, maybe sometimes it's maybe hybrid. Some database level tuning also requires sometimes skill tuning. So we have to check both aspects. Okay. And so that's it. So here, let's understand. Key takeaways. SQL tuning is individual SQL statement level. Database tuning is overall database level. Okay, execution plan and central. Okay, CPU memory, weights, concurrency, and major database tuning area. Always identify bottleneck before applying it. Okay, these are the key takeaways in the video. Okay, so don't tune what you are saying is the problem. Okay, tune what you measured. Prove is the bottleneck. Okay, so always what you should do, first identify the issue. The performance tuning, first identifying the issue is the problem. Okay, once you identify the issue, then you can usually fix it, because Oracle provided all the facility, the product itself. Okay, once you identify the issue, then you can able to fix it. Okay, that's what I want to share it today. Thank you for viewing the channel. Please subscribe if you already subscribed. Thank you for the support. I will be posting the videos alternate days. Please share your feedback. Please share your comments. Based on the input, I will be sharing the videos. I will creating the videos. Thank you.